So in this video, we're going to find the magnitude of the centripetal and tangential accelerations, as well as the speed of the particle. The question says, a particle has a non-uniform motion on a circular path of radius r is equal to 2 meters. At a given instant of time, the magnitude of its total acceleration is 10 meters per second squared. At this instant, find the magnitude, that is A, the magnitude of the centripetal and tangential accelerations and the velocity or the speed of the particle. So here we have been given is A, which is the A total, acceleration total is 10 meters per second squared, and the theta is 30 degrees, and we are told to find the AT, which is the tangential acceleration, the centripetal acceleration, and also the velocity of the particle, which we do not know. So from here, what we're going to do is we're going to come up with the components for A, since we have the common acceleration, or rather, we have the total acceleration, of which it comprises of the centripetal acceleration and the tangential acceleration. So in this case, when we resolve this, so we're going to find that there is going to be the tangential acceleration right at the tangent, and also the centripetal acceleration that comes to the center, or that is directed towards the center. So there is the tangential acceleration just as this. So this is the tangential acceleration, which is expressed as this. So this is the tangential acceleration, and also the centripetal acceleration, which is directed towards the center. So centripetal acceleration is directed towards the center. So what we're going to do is we're going to resolve this into components. So this is the A. This is the acceleration. This is the tangential acceleration, and the centripetal acceleration. The centripetal acceleration is directed towards the center. So from here, what we're going to do is we're going to express this in the respective components for tangential and centripetal. So here we are going to employ the trigonometric or the trig ratios. We're going to make use of SOHCAHTOA. So from this, we have, so for y component, we have sine theta. Sine is equal to opposite, which is this one, over hypotenuse, which is this one. So this is opposite, this is hypotenuse. So we have sine theta. Sine theta is equal to opposite. We have the AT, which is the tangential acceleration, over the hypotenuse. We have A, the magnitude of acceleration. So from here, we can express this like this. We make it the subject of the formula by simply cross multiplying. So 80 times 1, we're going to have 80, which is equal to sine theta times A. We have A sine theta. So this is the expression for tangential acceleration when we're given a scenario such as this. Then from here, so we proceed to the x component. The x component, so we have SOHCAHTOA. So cos is equal to, this is adjacent and this is hypotenuse. So the adjacent is this to this angle, and the hypotenuse is this one. So we have cos theta is equal to adjacent, which is AC over A. Then we make it the subject of the formula. So we're going to have A centripetal is equal to A cos theta. So this is equation number 2. So now for us to find the AT and AC, we just need to plug in the values. Is equal to A sine theta. So if we plug in the values, we have 10. So from here, we have 10 meters per second and per second squared. Then sine 30 is half. So half 0.5. So we're going to have 10 times 10, 0.5. We're going to have 5 meters per second squared. So this is the value for the tangential acceleration. And for the second one, we just make use of the second expression for, so this is the centripetal acceleration, which is equal to A cos theta, of which the value for A is 10 meters per second squared. Then times the cosine of 30. So this one, it is going to give us 8.66 meters per second squared. So this is the value for the centripetal acceleration. So from here, what we're going to do is we're going to find the velocity now, the velocity or the speed of a particle. So this is the third one. So we're going to have the third one. We know that the centripetal acceleration is found using, or rather, the AC, which is centripetal acceleration, is given by the velocity squared over r. So over 1, so we cross multiply, we're going to get v squared is equal to AC r. So from here, what we're going to do is we're just going to plug in the values, and when we plug in the values, we're going to have v squared is equal to the AC that that we have found is 8.66 meters per second squared. Then times we have 2 meters as the radius, 2 meters. So from here, 17.32 m squared per s squared. So from this, we just need to introduce the square root to both sides, and so when we do this, even here this one and this one will cancel, and what we're going to get is 4.1617 meters per second. So this can also be rounded off to 4.2 meters per second. So this is the value for the speed of the particle. Thank you so much.